Hello, in this video I'd like to tell you what is the geometric interpretation of the technique that you're going to see to identify quadratic equations. So let's start with a given equation, which I'm actually going to give you the particular equation in the lightboard later. So you'll have that quadratic equation, and what we want to do is figuring out what among the different types of quadratic surfaces you're going to get, or that quadratic equation corresponds to. So let me tell you already, the spoiler, that it would be a hyperbolic paraboloid like this one. So what we're going to see in this technique is figuring out what the cross-sections are. And the idea of a cross-section is that you're going to take planes that are parallel to your xy or yz or xz planes. So, for example, take this plane, and you're going to chop with that plane your surface. So, for example, if I have my surface oriented like this, and I take a plane that is parallel to your screen, what you see is that when I do the intersection, I will get a parabola. Whereas if suppose that my xy plane is in this position, and if I intersect that plane with this, what I would end up getting, so let me move this, is these two curves that correspond to a hyperbola. Whereas if I have a surface like this, if this was the surface corresponding to my equation, when I take my cross-sections with planes parallel to my xy plane, what I would end up getting is a circle, or more generally an ellipse, and in this direction I would end up getting hyperbolas. So that's a distinction between these two surfaces, that these will get different cross-sections than this one. So we'll see the specific situation for that example in the lightboard.